On this slide, we're going to talk about an unbalanced line. We've used a telephone line as an example. This represents the central office of the telephone company, and this represents the customer's premises. And these are copper lines running between the central office and the customer. This side is called a tip in the telephone industry, and this side is called the ring. Now, why would this line be, it appears to be the same length, why would we have an unbalanced pair where one side is shorter than the other? Now, electrically, one side may be shorter than the other. What causes this is if there's a problem on one side but not the other. You would find that this side would be a different length from this side electrically. Like if we use a meter and we put it right across from the tip side and the other side is connected to ground, or from the ring side and the other side of the meter connected to ground, you'll find that there's a different reading on the meter connecting to this side than this side. But in fact, they should both be the same reading, should both be infinite, because these lines here are not supposed to have any connection to ground whatsoever. So this is what if it is a ground on this side, it will be called a tip ground. If it is a ground on this side, it will be called a ring ground. Now, what caused this? We have to remember here that telephone lines are generally buried underground. And when these lines are brand new, it's fine. But as they begin to get older and they've been buried for a long time, the insulation breaks down, causing water to seep into the line. And what happens here is that when water seeps into the line and it gets mixed and the copper wire is exposed, what happens is that part of the current that's in here takes a different path through that water to ground. So now we're losing current to ground, and this is called a tip ground. And because of that, this side of the line look differently electrically than this side here, which doesn't have the ground. So this is what we call a tip ground. If it was on the ring side, it would be called a ring ground, and this caused the line to look differently. As a result of a tip ground or a ring ground, twisted pair technology stopped working. Got to remember that twisted pair technology totally depends on two things. It depends on the pairs being the same length, and for this twisted pair technology to cancel noise, and one depend on the other. If the pairs are not the same length, the noise is not going to be canceled. So these pairs, even though they're physically the same length, they're not electrically the same length. So any electromagnetic induction from external sources would not be canceled out. It would go right to the user. Any crosstalk will not be canceled out. It would go right to the user. So if the user is using a telephone here, you would hear noise and crackling sounds or whatever. If they're using say a DSL line, is a modem is on here, what's going to happen is that modem, the data getting through to that modem is going to be corrupted. So the service is going to be slow, and or depending on how severe this ground is, it may cause the line to fail totally. My name is Trevor from Telecom Training. Thank you for watching. If this video has been helpful to you and you are interested in more videos like this one, please hit the subscribe button below and you'll be alerted when the next video is released.